Of making the entry and out, though the mother is strict to determine at what time they should do what, but no one does that. So, mother feels it's a lot of disturbance for me. Every time you guys are coming and using the calling bell at night, 1 o'clock, there is a lot of disturbance. You are disturbing my sleep. I don't want to get that done. You can make a staircase side to side so that no one disturbs and still get onto the first floor. Or let us say, you wanted a private balcony, you already have the setting for that. Why don't you put a door side to side to make an entry into that room? So all you are trying to do is, you are not using your hallway, you are not using other common areas to enter into your room. That is what a snowflaking is. Right now you are going to see the same. Dimension table normalization typically is referred to as snowflaking. Redundant attributes are moved from the flat. Denormalized dimension tables and placed in the normalized secondary dimension tables. That's what you see in the snowflake schema. The flattened denormalized dimension tables with repeating textual values may make a normalization model comfortable. I just want to check if the recording is going on smoothly. Yeah, it is. So if the schema were fully snowflake, it would appear to be the full third normal form entity relationship diagram. Normal forms are generally in the OLTP world, but not in the OLAP world. But if you start moving towards the snowflaking schema, then you'll see, oh, it is like the normalized database and in the OLTP. You see it. Earlier, we know that there was one fact table with all the 4 dimension tables. Now, 2 of the dimension tables, like the brand dimension and the storage type dimension, are getting split or being added. And again, the brand dimension category has one more thing, which is a department dimension. You see there? Now it becomes a normalized database, which is the third normal form I can call, because they have put out the dependencies between the brand dimension, category dimension, and the department dimension. They have split them. There used to be one dimension table, but because every of them may not have the same data, and if they wanted to reduce the duplication, in the brand dimension table, if you keep on adding the category, which is more of a static one, the category won't change for every product dynamically. So they wanted to keep them out. And in the category dimension, still they wanted to put out the department, because they don't want to repeat the value of department in the dimension table. But to me, what I can say is, if the dimension table is crossing a limit of the data, for example, in your product dimension, you may have 1 million products. You are good there. But if it is going beyond that, what you'll do? You don't want the redundancy to happen. So you'll try to move out one dependent column from that and make it into a separate dimension, which we call snowflaking. That is the same story which I was explaining. You have 2 young children going to college, and they wanted a private area. They wanted to enter separately so that they won't disturb several other factors, So that's the same way we build this snowflaking schema. The dimension table should remain as flat table physically and normalized. So that is how a dimension table should be there. And snowflake dimension tables penalize cross-attribute browsing and prohibit the usage of bitmapped indexes. So that is more technical. What is a bitmap index is, if you look at it, if you have Sensex, for example, you have customers, you can put a bitmap index male customer and a female customer, which is the very highest level of the cardinality, but still bitmap indexes make it really easy because you chose, you wanted to do some analysis on the male customers. You can filter it, and the database is smart enough to go only to the male customer records because you have indexed it as male and female. I mean, you have put your index on that column. That is a bitmap index. And then display saving gained by normalizing the dimension table. As I mentioned you, when you split this dimension into more than one and make it into a snowflake schema, you are saving some space there, because if the product dimension is too heavy and you are running a report and it doesn't scan through the table, then you are in trouble. It should have a proper indexing, and if the indexing is not working, then they start splitting up the dimension into more tables so that it becomes friendly for the business to get out their report. So we knowingly sacrifice this dimension table space in the spirit of performance and ease of use advantage. That is the important thing why we do that. We do it in the spirit of performance and ease of use advantage. That is more for the performance thing. You are going to do the snowflaking. This is the last resort in an data warehouse. We don't be doing this very often, but still, yes, for certain domains or industries. For example, telecom. If you are maintaining a customer account customer dimension in the telecom world, AT&T in USA has 30 million customers. Then you are maintaining 30 million records in one table. It is going to be huge data. So after 30 million, if you start splitting them, will be better. For the address changes, you don't want it to introduce one more customer. Instead, you maintain the address table separately. Or even in the address table, the person may or may not move out of the region. He would be shifting his home locally. Then you better separate the region dimension. So there are several things that you can do to handle the performance of the data warehouse. Was there a question, guys? Types of dimensions. This is the terminology which you will be, which you must use when you talk to a business person. Conformal dimensions. I mean, I need not give you the definition of it because the name itself says it is conformal dimension, which means you are a confirmed family member, which means you are being relative in more than one. What is it? More than one. Marts, data marts. If a dimension is being shared between two data marts, then it is called as a conformal dimension. That is the simplest one-liner we can give. Was there a question? A conformal dimension is a set of data attributes that has been physically implemented in multiple database tables using the same structure attributes, domain values, definition and concept in each implementation, which is as simple as a dimension table that is being shared by more than one data marts or more than one fact tables. You can call it as a conformal dimension. Because why people call it as more than one fact table says, in general, you see only one fact table surrounded by 4 or 5 dimension tables in a data mart. But there is always a chance you may have 2 fact tables within the same star schema. Sometimes it happens. But the recommended way is to have one single fact table for one single business area where you want to explore your data, but sometimes it happens, people does that. Junk dimension. Junk dimension, the name itself says it. Junk dimension is convenient grouping of typically low cardinality flags and indicators. So low cardinality flag, what is this low and high cardinality? Cardinality is nothing but one to many and many to many kind of a join. So when you have low cardinality join, I mean, it is joining like our male and female. It is kind of a a join where you can say we are joining whether it is male or female. Very simple. So that you can call, if you have that kind of a dimension that you have put and built a bitmap index, then you call it as a junk dimension. A junk dimension is a dimension table consisting of attributes that belong in the fact table or that do not belong in the fact table or in any of the existing dimensional models. I mean, a male and female categorization you won't have in the sales fact table, because if you are purchasing, you cannot directly on the fly determine whether the customer is a male or a female and put it on your sales fact table. No, it is only an informational field, but it is not like. So a junk dimension is a dimension table consisting of attributes that do not belong in the fact table or any of the existing dimensional tables. So a simple definition is a junk dimension is not going to be connected to a fact table, guys. That is a junk dimension. Degenerate dimension. This is one of the important things which the people could be asking, but it is only terminology-wise. You can see like a fact is split into two. That's all it is. And so there are two dimensions dependent instead of one. So we are trying to see what it is. A dimension key such as a transaction number, invoice number, ticket number, or a bill of landing number that has no attributes and hence does not join to an actual dimension table. So the degenerate dimension here is, for example, you are flying from, as I have told you, the same information. You have a ticket. The ticket says like you are flying to more than one place, the multi-destination ticket. First you are flying from here to London, London to Dubai, Dubai to India. That's the example we can take. All the three flights are different. The fact is, you have booked the ticket, you have three flights under it. You can't join directly based on the booking number to your fact table. You can join only at the, you have three facts there. You have, first flight you took it from USA, San Francisco to London. That is one fact. And from London to Dubai is the second fact. And Dubai to India is the third fact. So you cannot directly join a ticket number to a dimension table. So this is kind of a degenerate dimension they call. Same in the invoice. In one invoice you have 10 different like if you look at our own invoice, for example, we have two transactions in there. One is the training fee, other is the server access fee. Those two, though part of the same invoice, they belong to two different dimension tables, and they collectively form as a fact. It is not like one direct entry. So it is a separate entry for those two. So that is called as a degenerate dimension. Degenerate dimensions are very common when the grain of the fact table represents a single transaction items or a line item. Was there a question?
Yeah, I got a question with you, Ganesh. Okay. Sorry to disturb you over there. If there are two facts, if you have two facts, those two facts are connected to each other or not? Or they're not?
They are not. Never I saw two fact tables are getting connected to each other, except the exception is only in the BI world. When you do the reporting, sometimes that is only a logical model you put together to have a shortcut join due to some other reason. But the physical model in a data warehouse, typically, there is no connection between two fact tables within one sales retail model.
Okay, thanks.
No problem. Degenerate dimensions often play an integral role in the fact table primary key. Yes. Degenerate dimensions, which means they are directly connected to the fact table, no doubt about it, but they are like each of these invoice can form more than one fact, and it can touch more than one dimension table. That is what I am trying to show you here. The role-playing dimensions, what this is? Role-playing, the name says something. So this is all for the terminology, guys. It's more or less in an interview. If you have tough time understanding what question they have given you, is going to be challenging. So You have to understand the terminology. You'll have to understand there are types of dimensions, there are types of facts. What is the data warehouse components, the architecture wise? People keep questioning you, so be smart. Just keep all this in your mind. Dimensions are often recycled for multiple applications within the same database. For instance, a date dimension can be used for date of the sale, as well as a date of delivery, as well as a date of hire. This often is referred as a role-playing dimension. That is the role of the mother. The role-playing dimension, you can take mother in the family, wife of your father, children of 3 other people, administrator for the entire home, and master for the kitchen. So she has several roles to play. So it is one date dimension table that we are using, but it will be used for several different reasons. So that is called as a role-playing dimension. Types of facts. Types of facts, not too many facts, very simple, semi-additive, additive, and non-additive. We don't need to just go through the entire presentation for that, because you all understand what is additive. You can add any number, but you cannot add the quantity across the units sold. You can add, units sold is very much object or a product specific. And if you are summing up them and say there are 20 products sold and I gain $1 million, it is better to have a little more details to get a proper answer. Semi-additive and non-additive. You do have semi-additive facts. If you want the definition wise, you can see here. Percentage and ratios such as gross margin are non-additive. The numerator and denominator should be stored in the fact table. The ratio can be calculated in the data access tool for any slice and dice of the fact table by remembering to calculate the ratio of the sums. Note the sums of ratio, not the sums of ratio. So few of things. Anyone who know basic mathematics, you can understand what we can add, what we cannot add together. Averages are something different. You can't add the averages together and say the average mark for a student is 102 marks. Never something student can gain, because it is an average. In percentages, you cannot add them directly, but you can do a cumulative sum of the percentages and it should work. So there are 3 types of facts as in the dimension table. Slowly changing dimensions. This is the most important topic for us for the day. Type 1 dimension. Methodology overrides old data with new data, therefore does not track historical data at all. This is most appropriate when correcting certain types of data errors, such as spellings of the name. Well, what are we talking about? What is this slowly changing, rapidly changing, not changing dimensions? One of you tell me, guys. What is this? Try to relate it to your the reality. As I was giving you an example of a single family home, an apartment complex, and a single family home, a mother, father, children. You relate it and say me what is slowly changing dimension.
Slowly changing dimension is nothing but data gonna be changed slowly, whereas like rapidly changing dimensions, the data gonna be changed like very rapidly.
That is true, but that is you are making an English definition of it. I want a little more reasoning why we call it as a very slowly changing dimension, though the data is changing. Not very often, but these dimensions can get updated every day. There is always there.
In slowly changing?
What is it?
In slowly changing, every day it's going to be updated? Yeah, of course. Yeah.
Yes.
You cannot download it.
Yeah, every day, whenever a customer changes his data, a phone number, whenever he changes his address, whenever he changes any part of his information, it can get updated. And the products, if you see, every day the products in the market are changing their values. It could be different flavors come up, different prices come up, every day the price may get revised. For example, dollar is a dimension, and the dollar rate keeps changing every day. So why they call it as a slowly changing dimension, type 1, type 2, and type 3 is the dimensions will be changing. I mean, we cannot compare between, we cannot say whatever the answer you gave is right. Rapidly changing dimensions, we can put the dollar amount, exchange rate is a very rapidly changing dimension. In a day, it can change more than once. But slowly changing dimensions, generally, it is a nightly load. When it happens, it may change. So the good way to design a data warehouse is always you look at the dimensions, see if there are any updates or any inserts of new dimensions. Then you do the dimensional load first and then come back and do the fact table load. But I know there are few organizations which they say, though the dimension doesn't exist, just load the fact. We will correct it at a later point, which I feel is a wrong methodology. But if we relate it in a real life scenario, slowly changing dimensions, type 1, methodology overrides old data with new data, therefore does not have historical data at all, which means you are a kid. Your mother has bought your a dress, a bouncer, a car seat. After 3 years, they are not useful because you changed it. One way is still you wanted to store everything that you started using from day one in your library or a storage case. That is, you are keeping the history of the items that you used. That will be, if you maintain the history in the same home, it means you are building a type 2 dimension. Whereas a type 1 is you override. My kid is not using this car seat anymore, just throw it out. I have only one car seat in the home so that there is no confusion, because who wants to keep all the data is, if you need some analysis, you're going to keep all the data saying how many times the customer moved from different locations. What are the trends within his movement? Is he moving too often? Then we put him in a different list. We give him a different deal. I have another business, packers and movers. This guy is moving too often, so let me analyze and give him an offer. It's kind of that, So slowly changing dimensions, no history. Whereas, in this example, supplier code is a natural key and supplier key is a surrogate key. You'll see the data now. Let me just go and pull out the data records, the small tables. This is the type 1 dimension, guys. Supplier key, supplier code, supplier name, and supplier state. A simple type 1 dimension. If you see here, now, let us say the supplier state has changed. How it will look is, it will just override. Whereas in the second case, which is a type 2, you are going to still keep the first record, add one more record, keep the history. The supplier has moved from California to Illinois. You are maintaining both the records. It is a type 2 dimension. If you are overriding and say, override his earlier location. Now I just wanted to see him as if so he is in Illinois only. So if someone wants to track the change, no, if you are not maintaining a type 2, you can't. So in general, so far, whatever the best practice I have seen in a data warehouse, customer is the very important ingredient. So, he is the core part. So always a customer dimension I have seen maintaining in a type 2 version. A product, not required. They just go with a type 1 because why do you want to keep tracking? But sometimes it is required because without having the product, the product price change, for example, let us say, or the item code or something which is very much required on the product, you can't tie back to any fact that you have captured. You are now telling a little soap has been sold, the quantity of a little soap sold in this month is 1 million soaps. Now the flavor has been changed, but it is still the same soap. You want to continue with a new number, that is fine. If you are maintaining the same number, you wanted to change the flavor or a price or something on the existing product, you have to maintain it in the type 2 dimension because that has to tie back to your fact. If you take it out, update it, then it doesn't tie back to your fact, then you are at a high risk. So in general, what I can say, all the type 2 dimensions are those which have a direct join to your fact table and which are more of the very important dimensions, like product is very important, customer is very important, region is very important. Those three I see always they maintain in the type 2 model. So definition wise, type 2 is method tracks historical data by creating multiple records for the same given natural key in the dimension table with separate surrogate keys and are different version numbers. So you version it saying this is the version 1, version 2, or you do it in the surrogate key, which is the supplier key I'm showing here, 1 to 3 and 1 to 3, 1 to 4. Those are just the sequential numbers which we are calling as a surrogate keys that we are assigning to this particular supplier. Or else he has his supplier code as ABC. It is Acme Supply Company. So with type 2, we have unlimited history preservation as a new record is inserted each time a change is made. Any questions on this, guys? Because in the next half an hour we are going to build the type 2 dimension. So I just wanted you to be clear about what this type 1 and type 2 is.
Can you have like a type 1 and type 2 dimension for the same data modeling or like for the same schema?
At the schema level, yes.
How about like at the data mart level?
Yes, that is correct. In one table, you cannot maintain type 1 and type 2. You can maintain a dimension in type 1 or in type 2, but at the schema level, yes, you'll have the combination of type 1 and type 2 dimensional tables. That is true.
So how about the data mart level?
You can also have that.
You can have it at data mart level?
Yes, obviously. Because here, date dimension is never going to be type 2. Date dimension is always a type 1 if you are overriding your any part of it. Or you can say, I have a promotion dimension. You can always overwrite it. Or it all depends upon which industry it is. It is very much related to business process. It is not like definitely across all the business, is this a true statement? No. It is always business driven, not like a person or a technical requirement driven. No.
Oh, okay.
So in a data mart, yes, the combination of type 1 and type 2 is permitted, and the reality is they are maintained in that way. Not all the dimensions will be maintained in type 1, not all the dimensions are maintained in type 2. If the business process says, I want to track the history of the customer, you maintain the customer history in the same table. And if they say, I don't want it to track the history of a region, I don't care how the regions have been renamed, because it sometimes happens you rename a particular city. You want to maintain it? Yes, you can, but the customer doesn't want to track. They want only currently how the name is called as Mumbai or Mumbai. Both are the same. Mumbai or Bombay is the same. But if the customer doesn't want to track, okay, give it the same name. I'm not interested in what name it is, but I have the join condition is not going to change because the Mumbai or Bombay has the same number, same pin code, same zip code, everything the same, right? So any questions on the type 1, type 2 dimensions, guys? Nope. Okay. Type 3 dimension, something new. Type 3 dimension, I have not seen any companies using this, but there can be a requirement in again, as I told, it is very much business specific. Type 2 is you have a limited history. Sorry, type 3 is you have a limited history. Type 2, you have unlimited history. Customer keeps moving from 100. The customer keeps moving. You can have 100 records for each customer. That is permitted if you use type 2 dimension. Type 3 is just the recent history. The most recent history is the type 3 dimension, nothing else. Which means I wanted to track the customer's last change, but not his entire lifetime change. Then you build a type 3 dimension. It is friendly because You are not having one more history record. You maintain the history in the same record in a different column, which means it looks like this. Supplier key is 1 to 3, supplier code is ABC, supplier name is Acme, supply company, original supplier state is California, effective date is this one, and then current supplier date is Illinois. You can make it using an effective date, that is one way, or you can do a flag, that is the other way, or you can maintain it both side to side, saying this is the old name, this is the new name, this is the old state, this is the new state, and the effective date for them. So this is the best way to build a type 3 dimension where you don't want too much of history for a certain dimension. Type 3 dimensions are very, I never seen company using it, but there could be, because my limitation is I have worked only on 3 data warehouse projects. It's not like every project I have gone through, but there are several places where they use type 3. And you typically keep it a very important point here and keep it really low. There is something called as a type 6 dimension. Trust me, don't get confused. It is just anyone can anyone guess what is a type 6 dimension, guys? Skipping the 4 and 5. Okay. Silence always indicates me to answer. Type 6 is just a combination of 3, 2, and 1. That is, in a data mart, all the 3 types can exist, but there is nothing like one physical dimension that you will build in type 3, type 2, and type 1. No. It is a combination always goes in a data mart. Each table has its own way of building. Whether you want it to do a type 1 dimension, type 2 dimension, or a type 3 dimension, it is all business driven. Oh, this is a question time, and we can take a break. First, I will take questions, and then we take a break. Any questions on whatever we are doing?
I do not have at this point.
Okay. I see some chat here. He will after theory. Well, what is this, Arvind? I didn't get actually. Arvind has put a note there. He will after theory. I think he is talking about one of the conversations we had, but I don't know what it is. Arvind, if you wanted any answer for that.
No, it's just a slowly changing dimension. Somebody asked, are you going to do the transformations on? Is there a lab or just a theory? So I asked, maybe.
Okay. No problem. We'll be doing the practical now. Type 1 and type 2 dimensions, we'll be building it. It's not going to take too much of time. Today we'll finish it off, and we'll catch up one other small presentation on data quality and learn a couple of data quality transforms also in today's class. So it's a time for a break.